Hey everybody, this is Dr. A, and in this video we are going to be discussing systems of equations, and we're not going to get into any big details in this video. This is just kind of an overview of what a system of equations is, specifically a system of linear equations, and just a list of some of the common techniques and methodologies we use to solve systems of linear equations. So let's go ahead and start with a basic definition. A system of n equations with n variables is a set of n equations, each of which is linear with the same n variables. Okay, so we've said in equations, quote unquote, in equations with n variables. Okay, and so what we're talking about when we say a system of equations is two or more equations with two or more variables. Now, we are only really going to specifically talk about systems with the same number of equations as the number of variables. So we're going to be talking a bit more specifically about systems of linear equations with two equations and two variables, or three equations, three variables, four equations, four variables, so on and so forth. Okay, so let's talk about their solutions. Okay, so a solution of a system of n equations with n variables is a set of numbers that is a solution of each equation in the system. Okay, and so when we think of a solution of a system of equations, we think of a solution consisting of one solution, none solutions, or no solutions, or infinite solutions. Okay, so we're going to change colors here, and we're going to say we could have one solution, no solutions, or infinite solutions. Okay, so if a system has at least one solution, it is called consistent. So it's given this special label as consistent. If it has no solution, then we call it inconsistent. So we're going to say a system with no solution is inconsistent. Okay, so basically, if you have a system that has either one solution or infinite solutions, then it is consistent. And if you have a system with no solution at all, then it is inconsistent, okay? So as I mentioned at the beginning of this video, we have several methods that we can use to solve systems of equations, okay? Now, depending on how big the system is, which means like, do you have 2 equations with 2 variables versus do you have 7 equations with 7 variables? Depending on how big the system is or what the coefficients of the variables are in your system, one method may be more convenient to use than another method. So, we can list them out. We can say common methods to solve equation systems. So one method is called the graphical method. The graphical method works best when you have 2 equations and 2 variables, and that's it. Once you start having more than 2 equations and more than 2 variables, the graphical method becomes tedious when you have 3 equations and 3 variables, and then basically impossible after you have a system that's bigger than 3 equations and 3 variables. So the graphical method is really only used when you have 2 equations with 2 variables. Another method is called the substitution method. Now, this method is also most convenient when you have 2 equations with 2 variables. It's also okay when you have 3 equations with 3 variables. Once you get to larger systems than 3 equations and 3 variables, the substitution method starts becoming very inefficient and very tedious, okay? We also have what's called the addition method, but it's also sometimes called the elimination method. Okay, this is pretty efficient for 2 equations with 2 variables, but again, like the graphical and substitution methods, once you get to larger systems, more than 2 equations and 2 variables, then it starts becoming very tedious and less efficient. And then we have matrix methods. Now, matrix methods are pretty efficient no matter what the size of the system is. And then there's a variety of matrix methods you could use for different systems depending on what the coefficients are of the variables. So this is the idea of systems of equations in a nutshell, just the basic idea of it. And in some subsequent videos, we're going to look into numerical examples using these different methods to solve various systems of equations. And that concludes this video. Go ahead, give me a like and a subscribe.